Good morning all. This is Satish Kumar, Assistant Professor of EC Department. Now let us see the video lecture series on combinational circuit, that is nothing but encoder and decoder. An encoder is a combinational circuit that converts binary information in the form of 2 power n input lines into n output lines, which represents n bit code for the input. For simple encoders, it is assumed that only one input line is active at a time. As an example, let's consider the octal to binary encoder. Octal means 0 to 7. Totally number of 8. D0 to D7. 8 inputs which produces the output as 3 outputs X, Y, Z. Input D0 to D7 represents which can produces the output as X, Y, Z. 8 is to 3 encoder. 8 input and 3 output. This is the 8 is to 3 encoder truth table. D0 to D7 we can take in totally 8 inputs, output X, Y, Z. When the D0 is high means output will be 0, 0, 0. D1 is high means 0, 0, 1. D2 high means 0, 1, 0. D3 high means 0, 1, 1. D4 is high 1, 0, 0. When the input D5 is high, one output will be 1, 0, 1. When the input D6 is high, the output 1, 1, 0. When the input D7 is high, 1, 1. Therefore, the output can be represented as X is equal to D4 plus D5 plus D6 plus D7. Y is equal to D2 plus D3 plus D6 plus D7. Z is equal to D1 plus D3 plus D5 plus D7. Now let us see the logic diagram. 8 is to 3 encoder logic diagram. Input can be given as D0 to D7. X is equal to D4. When we combine D4 plus D5 plus D6 plus D7, that can be combined with OR gate, which can produce the output as X. D2 plus D3 plus D6 plus D7 combined with OR gate, which can produce the output as Y. D1 plus D3 plus D5 plus D7 combined with OR gate, which can produce the output as Z. This is the logic diagram of 8 is to 3 encoder. Next one, decoder. 3 is to 8 decoder and its truth table. And decoder is the opposite of encoder. It is a combinational circuit that converts n lines of input into 2 power n lines of output. Let's take an example of 3 to 8 line decoder. 3 inputs are X, Y, Z. 8 outputs are D0 to D7. When the input 0, 0, 0 means D0 is high. Input 0, 0, 1 means D1 is high. 0, 1, 0 D2 is high. 0, 1, 1 D3 is high. 1, 0, 0 D4 is high. 1, 0, 1 D5 is high. 1, 1, 0 D6 is high. 1, 1 D7 will be high. This is the truth table of 3 is to 8 decoder. Now let us see the logic expression of decoder. D0 is equal to X bar, Y bar, Z bar. D1 X bar, Y bar, Z. D2 is equal to X bar, Y, Z bar. D3 is equal to X bar, Y, Z. D4 is equal to X, Y bar, Z bar. D5 is equal to X, Y bar, Z. D6 is equal to X, Y, Z bar. D7 X, Y, Z. Now we can see the logic diagram. Logic diagram for X, Y, Z that can be combined with NOR gate X bar, Y bar, Z bar. D bar means X bar, Y bar, Z bar. 0, 0, 0 represents D0. X bar, Y bar, Z 0, 0, 1 represents that can be combined with AND gate D1. X bar, Y, Z bar, D2. X bar, Y, Z combined with AND gate D3. X bar, Y, Z, D3. X, Y bar, Z bar, D4. X bar, X, Y bar, Z, D5. X, Y, Z bar, D6. X, Y, Z that can be combined with OR gate D7, which can produce as 3 inputs X, Y, Z, which can produce as output as 3 D0 to D7. Now let us see the applications of encoder. Data conversions in digital system. Conversion of octal memory address into binary memory address. In microprocessor microcontroller to convert octal instructions into binary format. In communication system to encode octal data into binary form for transmission. Decimal to BCD decoders is used in digital clocks, timers, data processing devices, storage systems, calculator, display devices, microprocessor, microcontroller, embedded systems, etc. Next, we can see the applications of decoder. Decoders are used for code conversions, are extensively used for memory systems of computers, are used for demultiplexing or data distribution. Decoders are used in data routing applications where short propagation delay is required. Decoder may also be used for timing or sequencing purposes. Decoders are utilized to turn on and off digital devices at a specific time. Now let us see the assessment. Define encoder. Encoder means encoder which can produce as 2 power n input lines, which can produce as n output line. That is nothing but 8:3 encoder. 8 inputs D0 to D7, which can produce as outputs as 3 outputs X, Y, Z. Recall the Boolean expression for encoder, therefore which is equal to X is equal to D4, D5, D4 plus, D5 plus, D6 plus, D7. Y is equal to D2 plus, D3 plus, D5, D6 plus, D7. Therefore, Z is equal to D1 plus, D3 plus, D5 plus, D7. List the applications of encoder. It is used for conversion of octal memory address into binary memory address. In microprocessor, microcontroller, octal instructions can be converted into binary format. In communication systems, to encode the octal data into binary form for transmission. It is a combinational circuit that converts dash lines of input lines into dash lines of output. A decoder is a combinational circuit that converts n lines of input into 2 power n lines of output. Recall the truth table of decoder, which can produce, it can consist of 3 inputs and totally 8 outputs. 3:8 decoder. 3 inputs means X, Y, Z. Truth table D0 to D7. When 000 means D0 will be high, 001s D1 will be high, 010 similarly for D2, and then 011 D3, 010 D4, 011 and then 110 we can get it as your 111. Similarly for 0 to 7, the D0 to D7 will be high. In for the applications of decoder, decoders are used in code conversions, are used for demultiplexing and data transmission, are used in memory systems of computers. Thank you.